Welcome back. So, we know how to do a lot from a quantitative data set at this point. We can make a frequency table out of it that includes frequencies, relative frequencies, and cumulative frequencies, along with class limits and class boundaries. And we know how to make two separate graphs, both histograms, based on the information in the frequency table. We can make a basic histogram that has frequency on the vertical axis, and we can make a relative frequency histogram that has relative frequency on that vertical axis. So I thought we'd start today's video by saying, what can we say about the shape of the distribution if we're looking at a histogram? So, in our notes here, we've got several different shapes that you can see when you look at a histogram, several basic shapes. So the first one is symmetric unimodal. So symmetric means the same thing that it did in art class. It means the same thing that it does in just regular English. So for example, in this distribution right here, if you were to take this graph right down the middle vertically and fold it on top of itself, it would match up exactly. And so this distribution would be considered symmetric. Now, what's interesting about statistics is this distribution here is also considered symmetric. But obviously, if we take a vertical line down the, I'm guessing is the middle, and we fold it on top of itself, it's not going to match perfectly. But here's the secret, and this is what makes this different than a mathematics class. We're not going to see perfect data sets in real life. Things that look like this don't happen, ever. We will get data sets that look like this. And what I want you to look at when you see a distribution like this is not the individual bars. Those aren't as important as the general trend or the general shape. So when I look at this histogram, what I see is it starts low on the left side and it gradually goes up, it peaks somewhere in the middle, and then it comes back down to the right. I'm not necessarily interested in whether this bar is taller than this bar or whether this bar is shorter than the bars around it. I don't care about that stuff. Just the general shape is what we're interested in here. So instead of calling something symmetric, in statistics, we're fond of saying roughly symmetric. That's what's important here, because you're not going to see perfect symmetry out in the wild. It's not going to happen. This is about as good as it's going to get. Now, the unimodal part of this, uni meaning one, like a unicycle has one wheel. If people are wearing a uniform, their form of dress is all the same. Unimodal means there's one mode in these distributions. So you can see in this one in particular, that mode right there in the middle. Now, in this graph, you might be tempted to say that this bar right here, this single bar is the mode because it's the tallest bar. And again, we're interested in the general shape. I wouldn't say the mode is this bar. I would say the mode is this grouping of bars in the middle. Again, it starts out low, goes high, comes back down. The highest group of bars I would consider the mode. So, if there's one mode and it's roughly symmetric, we would call it symmetric unimodal. And it turns out, spoiler alert, these types of graphs, the symmetric unimodal ones, are super important in statistics because there are lots of things that we can say about distributions like that. There are lots of things that we can determine if the distribution has a shape like this. Now, there are other shapes. Next is uniform. And so, like I mentioned earlier, uniform means all about the same. Now, a uniform distribution does not have to have all the bars in the histogram be exactly the same straight across. Again, that's never going to happen in real life. So, we would consider both of these graphs uniform. And that might seem a little strange at first because they're not all the same. But when we look at the general trend, we don't really see any peaks or any valleys. They're all roughly the same. To split hairs on a graph like this and say that these bars are taller than these bars, so that it has a peak here and then another peak over here, I think that's being a little too cute. We would say that those are all roughly the same, and the general shape here is pretty uniform. Even the same thing here. This is even a little less uniform. Look how short that bar is compared to some of these up here. But again, I wouldn't necessarily say, oh look, it peaks again, and then it goes back down. That's taking too fine a point to it. If we're going to look at the general shape, there's no real defined peaks. So it's considered uniform. And that's a little tough for some people to get used to. Well, if this is uniform, then what isn't, you know? But you can see the difference between these two groups of histograms. We definitely wouldn't call these uniform, right? And there will be some distributions that are more like these, and uniform is the best that we can say about it. That's just the way it is. So, uniform distributions are also roughly symmetric, but we don't necessarily need to say that because uniform implies symmetry. Let us move on. Okay. So, not all distributions are symmetric. Some are skewed in one direction or the other. And what we're saying is these two histograms show distributions that are left skewed. Both of these are left skewed, and both of these down here are right skewed. And people tend to mix that up and say that it's skewed in the wrong direction, and I think that's because people say, oh, for these graphs, most of the data is on the right side, so it must be right skewed because it's most of the data is to the right. But what I want you to do so that you never forget or mix this up, and this is why I have a Word document here and not just a PDF because I want to mess with it. This is my foolproof method for how to always correctly identify which direction a distribution is skewed. If there's a skew one way or the other, I want you to put an arrow on top of the histogram with the point end on the mode or the group of bars that would be the mode. And draw your arrow pointing towards the longer tail, the longer end of the histogram. Oh, that's a wimpy arrow. We can do better than that. We can do better. Let's make it red, and let's make it thick. Yeah, look at that guy. That's awesome. So, if you do that, and you make an arrow pointing toward the direction of the longer tail, the direction your arrow is pointing is the direction of the skew. So this is left skewed. And, similarly, if you've got a skew in the other direction, you would put your arrow point, or your arrow dot here, and then point your arrow toward the longer end. So we gotta go wee, boop. That one's right skewed. Same with this one. Okay, so if you use your arrows, you will always correctly identify the skew as long as you know the difference between left and right. Maybe that's tough for some people, I don't know. But as long as you know left from right, you should never mix up the two directions of a skew for a distribution. And this is probably the thing that will show me whether people are watching this video, because you will be asked to identify this on a future test or quiz. I can guarantee it. And people who do it right, maybe they watched the video, maybe they didn't. But if they get it wrong, I'm pretty sure they didn't watch the video. So if you're watching this right now, make sure you get this right. This is something pretty simple. You should not ever mix this up now that you know the arrow trick. So we've got unimodal symmetric, we have uniform, and we have left and right skew. There is one other type I want to highlight here, and that's a bimodal distribution. So in contrast to unimodal, bimodal, bi meaning two, these distributions have two clear modes. Clear, right? So like on this distribution, we've got a peak here comprising these two boxes, or these two bars, and then there's a gap of several bars before another peak, right? I want you to contrast these two distributions to, say, these two, where there's no clearly defined peak or valley really anywhere, right? It will be obvious. And in both of these, it is quite obvious. So Bimodal, you don't really have to say anything else about it. You probably won't be shown any distributions that are bimodal and skewed. That would be hard to do. And you won't be shown any distributions, at least not in this class, that have more than 2 peaks, although they do exist. They're kind of rare, though. These are the main shapes that you're going to need to identify. So as long as you've got those straight, you should be good. So, now that you know how to describe the shape of those histograms, there is one more graph that you will need to be able to make. And it's this one. Any ideas how that's pronounced? The most common answer that I see, or that I hear, I guess, is Ogive, like olive, but with a G instead of an L. But this is actually pronounced Ogive. So, we've got, from a frequency table, from that information, we can create a basic histogram, we can create a relative frequency histogram, and we're going to learn in a minute how to create an ogive. But in order to do that, I need to go back to the board. So give me a sec to go back there. All right, let's make an ogive. So we've got our steps right down here. We just need to follow them. One word of caution. An ogive is not a histogram. There's a reason we don't call it a histogram. It's actually a line graph. So the steps here are going to be a little different. It does have some things in common with the other 2 graphs, but it is quite a different graph. So if you need to put stars in your notes around ogive to convince yourself this is a very different graph, please do that, because we will see some major differences here. Step 1 is always the same though. First thing any graph needs is a title. And we're going to be using the same data as we did for the other graphs in the previous videos, the basketball scores. So our title will be the same. Same title. It's the same data. Again, a more specific title is better than a less specific title. There should be no doubt as to what your graph is representing. Step 2 is to label your axes, but we currently lack those. So let's make our basic L shape again. And it says the vertical axis is the cumulative frequency for the ogive. So for the basic histogram, frequency was on that vertical axis. Relative frequency histogram was relative frequency. Now we're going to get to use the cumulative frequency for the ogive. But again, the reason this isn't called a cumulative frequency histogram is that it's not a histogram, it's a line graph. We'll get to that in just a sec. We need to label our horizontal axis as well. And it will be labeled the same way as the histograms. This is what the data is. This is what the data is. So we've still got winning scores down here. And again, the most common mistake for all 3 of the graphs is that people label this axis class boundaries, because that's what you're going to be seeing on the scale here. But this is where you say what your data represents. Label axes is done. Step 3, write cumulative frequencies on the vertical axis. Okay, so we need to figure out what values to put on this axis to scale it. Same idea as the other graphs. We need to find out what goes up top first. We would obviously want that to be the highest cumulative frequency in our table. So for this data set, cumulative frequency goes up to 30. I think that's a nice round number to put up here. If that number were like 32, I might consider making that 40. But since 30 is a nice round number, I'll put it up there. We should probably divide this up a little bit more than just putting 30 at the top. I could cut it in half and put 15 here, but then that would put me in kind of a bind if I wanted to cut it in half again. I'd have to start involving decimals. I don't want to go there. So I'm going to instead cut this into thirds, or attempt to. Make that 10 and 20. That's not too bad. It's not perfect, but I'm not a straight edge kind of guy. And I feel like for my graph, since it's so blown up on this big board, I can take the space and go by 5s. And I think that that works really well for my graph. Maybe for you, going by 10s is fine. Maybe it looks a little crowded if you put the 5s in there. Again, this is more of an art than a science. Although I think the 30 up here in this case is pretty non-negotiable. It should be 30. How you divide it's up to you. Okay, that's step 3. Step 4, that's this many. We write the class boundaries on the horizontal axis, just like the other 2 graphs. So again, every number in this class boundaries column of the frequency table is going to find its way onto this axis, starting with 65.5. And then it's going to be every unique number in here. So 71.5, 77.5, 83.5, 89.5, 95.5, and 101.5. Oops. I could do a better job there. There. Should be a little easier to read. Cool. So we've got our title, axis labels, and axis scales done. That's steps 1 through 4. So, as I said before, this is a line graph, not a histogram. So we're not going to be drawing bars, we're actually going to be making a line, but we need to put the points to tell the line where to go. So, step 5 is the step that everyone forgets. I've been teaching this class for several years, and when people make ogives, well, the most common mistake is that they make a histogram, which is just wrong, is a line graph. But the second most common mistake is that people don't do step 5, which is to put a dot over on, ignore the word over, I don't know why that's there, put a dot on the horizontal axis at the lowest class boundary. So in this example, that's going to be 65.5. Put a dot on the horizontal axis at this value. Why that dot needs to be on the axis is because what we're graphing here is the cumulative frequency as we go through each class. This number is the beginning of the first class. There are no teams of these 30 that won and scored this many points or less. There are none, 0. So that first dot has to be at 0. The next class boundary, 71.5, that's the end of the first class. There are 3 teams that won and scored somewhere in between here. So this one's 0, this one gets a dot at 3. The mistake is to put this one at 3. That will make all the other ones off, and then you won't have any dot to put here. That will mean that you screwed up. Okay, so I'm trying to prevent you from making the same mistakes as students in the past. I'm trying to evolve you. Put that dot, that first one, on the horizontal axis. Then there's at 3, and then for every subsequent class boundary here, so 77.5 is the end of the second class. Now we're up to a cumulative frequency of 10, so this one goes up to 10. And we continue that pattern for all the rest of these. 83.5 goes to 17. My apologies if this looks a little off. It's very difficult to judge space in this vast area. 95.5 goes to 28. And 101.5 to 30. Okay, so maybe yours is a little more accurate. Again, if you're someone who really likes to have straight lines and be as precise as possible, I recommend making all 3 of these graphs on graph paper. That will help you keep things straight and equal. But with me and this giant whiteboard, this is the best I can do. Your dots should be in this type of pattern. So we've done steps 5 and 6 on this list by making these dots. All right. You'll know you've done it right if each of these numbers has a dot over it. If you run out of dots too early, this is probably your issue. Okay. So once we've got all our dots, it's a line graph. Let's make a line. Now, this looks like it would be a pretty dope curve, right? That looks pretty beautiful, actually. But we're actually just going to be connecting 2 points at a time with line segments. So there shouldn't be any curves here. If there are any, that's my fault. See, like that one already curved. We're connecting 2 points at a time with straight lines. That's the goal here. And making a racket as we do it, apparently. Sorry. So, should look something like this. Make a dot, blah, blah, blah. To check your work, again, to check your work, make sure you did it right. The rightmost point, its coordinates should be the last upper class boundary from your table, comma, the last cumulative frequency, which should be the same as the number of values in your data set. If that's not your rightmost point, something's missing, and again, it might be that you started too high here. So, that is your ogive. Again, it's not a histogram, but as long as you follow the steps, not terribly difficult. So, let's recap everything we did in this section because we were in this section for a very long time. This is probably actually the longest section of the entire semester. We start with a data set. From that, we create a frequency table. You can make all of the columns now. You've got your class limits, your class boundaries, your frequencies, your midpoints, your relative frequencies, and your cumulative frequencies. All of those columns in your frequency table. You also know how to create a basic histogram, a relative frequency histogram, and now an ogive. And based on the histograms, we talked earlier in this video about what you can say about the shape. So, you have 3 homework problems for this section. Maybe you've already started on it. You probably should. You'll need to do all of those things for each of 3 data sets. And if you try and do it all at once, I hope you have a large block of time ready because it's going to take a little while. Hopefully you've been doing it in pieces as we've gone along through these videos. That will give you great practice on how to do all these things. You should be a master of creating frequency tables and all 3 of these graphs by the time you're done with the homework. However, if you feel like you need a little more practice, the last page of the notes, gives you an additional example. So I've given you snowfall values for Indy over a long time period, and you can create a frequency table, a basic histogram, a relative frequency histogram, and an ogive based on that data set. Just if you need more practice. You are not turning this in. I don't want to see it necessarily. If you want to do that and then check your work, I can take a picture of the key and send it to you if you want. I'm more than happy to let you know if you're doing that right. But between the homework and this extra example, you should be in great shape. If there are any questions, please always contact me. And you will have a quiz over this section where I give you a data set and ask you to do all of those things. That will actually be, I think, the e-learning day after this video is assigned. So it's right there. So definitely by the time you're done with the quiz, you've had plenty of practice on all of these things. So when the Chapter 2 test comes around and I ask you to do some of that stuff, you'll have it down. That's the hope. So you've got a lot to do. Got homework to work on, a quiz to study for perhaps. As always, let me know if you have any questions. But otherwise, we'll see you in the next video. Have a great day.